Hey y'all, Miss Harper here for our Pythagorean Theorem notes. So I know y'all are like, oh, Pythagorean Theorem, that's so easy. Well, we're going to upgrade it a notch by using what we've learned earlier this year about simplifying radicals and give you a better preview of what it's going to look like next year in geometry. So maybe you remember that the Pythagorean Theorem is a squared plus b squared equals c squared. Alright, most important thing here is that this can only be done with right triangles. And most importantly, this guy right here we call the hypotenuse. Hypotenuse. He always has to be C. So he's always going to be the guy across from the 90-degree angle, and he's also the longest guy on your triangle, the longest side. The other two sides, it doesn't matter who you call A or who you call B, so we'll just label one of them, and we call those things a leg and a leg. So again, most importantly is our hypotenuse, the longest side, opposite from the 90-degree angle. Next thing we want to write down are the perfect squares. So if you remember that nice list we went through earlier this year, the way that we get that is by multiplying a number by itself. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so forth. So we're going to list all those out. 36, 49, 8, 9, 10, 11, and 12, 13. We'll stop there. Alright, so make sure you get all those listed. Now, if it's going to be helpful for you, you're welcome to maybe in like another color or something, you can put the square root of that number above it. So the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. So you're welcome to list those numbers above or below if that helps you out. Alright, and then our steps for simplifying radicals. So first step is find largest perfect square factor, meaning finding the largest one of these red numbers that fits into our given number. 2, we do our factor pair. And then step 3 would be to simplify the perfect square. Okay. All right. So let's go ahead and dive in here to number 1. Okay. All right, so again, most importantly, first thing we want to do in this Pythagorean theorem is label our sides. So you should maybe always start with your C, because it's most important who we label C as. It doesn't really matter who we call A and B. So again, opposite from my 90-degree angle, my longest side is C. I'll call this guy A and this guy B. Now from here, I'm going to plug it into my formula. So I have A squared plus B squared equals C squared. So that's going to be 6 squared plus X squared equals C squared. Okay, now I can kind of simplify this a little bit. So I have 36 plus X squared equals 100. And now from here, our goal is to isolate our variable X. We're trying to figure out what is the value of X. So now I would subtract 36 from both sides. And when I've done that, I will have X squared equals 64. And now here's an inverse operation for us, all right? So to isolate variable x here, I need to get rid of this exponent. So to get rid of something squared, we do the opposite operation, and in that case, that means taking the square root. And those two things cancel each other out, but whatever you do to one side, you have to do to the other. So those two operations cancel each other out. I'm left with x equals the square root of 64. And the square root of 64 is one of our perfect squares. The square root of 64 is 8. All right, so that would be our answer. And now this one worked out really nicely where we got a beautiful, nice, perfect square whole number. Let's see what happens on number 2. Alright, so again, starting with my C, I'll label this guy A and this guy B. It really doesn't matter who you call A and B, but it does matter who you decide to call C. So this time I'm going to have 10 squared plus X squared equals C squared. Alright, so again, that's going to be 100 plus x squared equals 121. And again, I want to isolate my variable x by subtracting 100 from both sides. And I'm going to be left with x squared equals 21. All right, and same thing now, I need to take the square root of both sides. Boom, boom. Now here's the problem. The square root of 21, we're about to see, is not a perfect square. All right, so it's long, long decimal. So what we're going to do is that we're going to try to simplify the square root of 21. Now remember, whenever we try to simplify, we want to see, do any of these numbers divide nicely into 21? Well, obviously 25 is not going to go in there, and if you're not sure, we'll do 21 divided by the next number, which was 16. Doesn't fit nicely into there. 21 divided by 9. Doesn't go nicely. 21 divided by 4, and again, none of those are perfect or factor pairs. So in this case, the square root of 21 is the most simplified version of this radical. All right, he's in his most simple terms, so that is another kind of easier one. All right, let's take a look here at number 3. All right, this is going to be my C. I'll call him A, and this guy B. All right, now this is where things start to get a little weird. 10 squared plus 7 squared equals x squared. Okay, oops, I should use parentheses. It's always a healthy habit. All right, so if you tried this in your calculator, it's one way to do it. You could do the square root of 10, squared. All right, but we just learned that those two things are inverse operations. It's like saying to multiply something by 10 and then divide it by 10. You're going to end up at the same number because they're opposite operations that cancel each other out. So the same thing is happening here. I can square the square root of 10, but we end up back at just whole number 10 because, again, these two operations cancel each other out. So that's just regular 10 plus regular 49 equals x squared. All right, so now I'm solving for x, who is already isolated. So this is, I can combine these terms over here and say that 59 equals x squared. I need to take this a step further by taking the square root of both sides. Those two operations will cancel each other out. And again, the square root of 59 is not a perfect square. So from here, I again want to test and see, do any of my perfect squares divide nicely into 59? I'm just going to tell you, and this time the answer here is no. 59 is as simple as he is going to be. All right, let's take a look at number 4. All right, so same thing, always labeling C opposite from the 90-degree angle. Doesn't matter who we call A or B. So I'm going to have x squared plus 5 squared equals 9 squared. So this is going to be x squared plus 25 equals 81. And again, solving for x, I'm going to subtract 25 from both sides. And I'll get x squared equals 56. Take the square root of both sides. All right, so now again, I need to check and see, does the square root of 56 simplify? He's not a perfect square. So remember, we want to work backwards down this list of our perfect squares to see if any of these numbers fit nicely into there. So let me pull up my calculator again. 56 is our number, so let's start 56 divided by, hopefully you know 49 doesn't go in there, but if you're not sure, just do that. 56 divided by 36. 56 divided by 25. 56 divided by 16. 56 divided by 9. 56 divided by 4. Oh, actually, oh wait, 56 divided by 4. There we go. All right, and so right there, I did find my perfect square. 4 is the largest perfect square. So I'm going to break this down into a factor pair now. And that got ugly. All right, so this is going to break apart into the square root of 4 times the square root of 14. All right, but I know what the square root of 4 is. It is 2. So this becomes 2 square root 14, and that is the length of our missing side here. That is the side A, our leg, or X, that's the missing side there. So again, you could either end up with a whole number, a square root that does not simplify, or a square root that does simplify. You just have to check and see what you have going on. All right, let's talk about a little special example here, number 5. All right, so again, I'm going to label C first. He can be A, he can be B. All right, so I'm going to have 5 square root 2 squared plus B, or X squared. x squared equals c squared, or 11 squared. All right, so this one gets weird again. All right, so let me break down 5 square root 2 squared and show you what's happening with this thing. All right, so that just means something times itself, right? So this times this. So it's kind of like the relation I usually make is something like this, 5x times 5x. All right, so it's kind of similar. Our whole numbers, our regular numbers are going to multiply together, and then our radicals will multiply together. All right, so regular 5 times regular 5 is regular 25. All right, now square root 2 times square root 2. You can plug that in your calculator. So it's the square root of 2 times the square root of 2, which would equal the square root of 4, but we know the square root of 4 is 2. So again, these two things kind of, these processes kind of cancel each other out. Anyways, it just ends up being whole number 2, but it's 25 times 2. So it's a little tricky and a little confusing. If you have questions over this part, you're going to have to come ask me. All right, because this is saying 5 times the square root of 2. So this becomes 5 times 5, which is regular 25. Root 2 times root 2 is regular 2. And then we end up doing 25 times 2, which is 50. So this whole thing just becomes straight up 50 plus x squared equals 121. All right, so again, if you need help on that piece, come and see me. I'm going to subtract 50 from both sides so I can isolate my variable. I get x squared equals 71. And then again, coming through here to take the square root of both sides, and I get x equals the square root of 71. Now again, because I'm Miss Harper and I'm the math teacher, I know that that's not going to simplify any further, but you don't know that, so you need to make sure that you're going through your list of perfect squares to see if this thing simplifies first. All right, why don't we go ahead and pause this last example and you try this one on your own. And it doesn't say which variable you should be solving for or which side, but we'll call this side x and call him c, our hypotenuse. All right, if you're coming back on with me, hopefully your work looks similar to mine. We ended up here with x equaling the square root of 109, and that guy does not simplify any further. So if you ended up there, you got the right answer. All right, after you finish your notes, you should be working on, I believe, the back side of your assignment for practice. Good luck. If you have any questions, please ask your math teacher, and don't forget to like and subscribe below.